So we're now going to look at these functions based on the graph and analyze them to come up with an equation. To find the least possible degree, we need to look at the x-intercepts and the behavior at them. So in question A, we have 3 x-intercepts. All of them pass straight through, so they're all multiplicity 1. So in A, the degree would be 3. In B, we also have 3 x-intercepts, except this one here at 4 bounces off, meaning it has a multiple. This x-intercept at 4 bounces off the x-axis, meaning that that x-intercept has a multiplicity of 2. So we have multiplicity of 2, multiplicities of 1 here, meaning our degree would have to be 4. The sign of the leading coefficient, this is where we look back to the end behavior. In A, we're going up, left, right, meaning the leading coefficient would have to be positive. In B, we've got a parabola-like shape, which is opening down, meaning the leading coefficient would have to be negative. X-intercepts, these are identified quite easily. In A, we have an x-intercept at -4, at -2, and at 2. In B, we have x-intercepts at -5, -1, and 4. The equations So the equation of the function now is relatively easy to determine. So in A, we're going to have y equals, we know we have a positive leading coefficient, so we'll leave the leading coefficient positive. Each of the brackets of the factored form of the function will come from the x-intercept. So we'll have an x plus 4, which would give us the minus 4 x-intercept. We'll have an x plus 2, and an x minus 2. In B, slightly different, our leading coefficient is negative, so we need to account for that by putting the negative. We'll have an x plus 5, x plus 1, and x minus 4. However, that x minus 4 has to be squared due to the zero behavior, of that graph at 4.